diamond ring for my queen. You gon' wait me till Jesus come. Why when I talk? Pocket full floss, money, honey, forget about Suzanne. So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, start with what you have, and then from there you're gonna elevate it. You're gonna elevate it, and things gonna propagate it, and just me, and things gonna improve slowly, because you can't reach down top before top player.
There was a time when immortality seemed the way to enchantment and happiness.
Hello, how you doing, brother and sister? So I'm we have a question right there. So we have to integrate square root of tan x dot sec power 4x dx. So first and foremost, this is very simple. This is trigonometric integration, because this is trigonometric. So first and foremost, I want to show something which is very, very important, and you're gonna see it in regular basis when you solve trigonometric integral. So this one here shows the second. We know from the trig identity, if somebody gave you, let's say, sine square, let's say theta plus cos square theta is equal to 1. But we can create other identity from these very basic identity, you know what I'm saying? So look, we want to get sec, we want to get tan, we want to get sec and tan. So excuse me. So what I have to divide here to get sec or tan? So means I have to divide by cos here. 1 over cos equal to sec, so cos square of theta, but you have to divide throughout, because 1 over cos equal to sec. So 1 over cos equal to sec, so we want to get something at the sec or tan. So 1 over cos equal to sec, so I'm going to divide by cos square everywhere, cos square, divide everywhere by cos square. So this 1 over cos square equal to sec square, and the cos divided by cos equal to 1 plus sine over cos equal to tan. So you see, tan and sec, they're both in this equation. So we're gonna use these a lot of time. We're gonna see these, we're gonna use it a lot of time. But for now, this and this. But for now, we're gonna use these according to the equation, because in the equation we have a sec and tan, and you can see there's a tan and sec. So we're gonna use these for now. Now let's try to solve this question. One of the easy questions. So we say, excuse me. So whenever I see sec, means when the sec is 1 tan square plus 1. But sec square equal to tan square plus 1. So now, since it's sec square, so let's make this as a sec square. So okay, so if I had to rewrite this, okay, so integral tan x, and then we have a square root in there. So this is sec square. So say it's like say sec square of x, but there are two of them, this square dx. Or you can say sec square times sec square. Let's do it. Sec square times sec square dx. Why? Because I'm going to substitute tan square plus 1. So I'm saying? So then we're going to say, excuse me. Now we're going to say, so we have this. So now let me say, what is sec square? Sec square equal to tan square plus 1. But don't change them both. You see? Don't change them both. Just only 1. You see? Sec square. Or, excuse me, let me show the easy way. Now, let tan equal to any letter, because this is going to be trigonometric substitution. So let tan equal to any letter. So we say, okay, let's say me, which one over bantu, our current equal to tan of x. But when you differentiate this, it's going to give us dm equal to tan of x, means sec square of x. You have to refer to the trigonometric table. When you differentiate tan, you get sec square. So sec square x dx. So then this, look, sec square dx, sec square x dx is this one. So we're gonna replace it. We're gonna write what? dm. And this tan here, we're gonna write m. Everything has to be mm. So this is gonna be sec square x dx equal to dm. And then tan of x m. So this also has to be as a m. So we're gonna say, all right. So sec square equal to tan square plus 1. But what is a tan? Tan equal to m. So we're going to say, okay, so m plus 1, m square, excuse me, means tan square plus 1, but tan equal to tan of x equal to m. So we're going to say m squared plus 1 equal to sec squared. So let's substitute back. So let's substitute back all the values. So it's an integral. So everything must be in m now. Square root of tan equal to m multiply sec square. But what is sec square? Sec square equal to tan square plus 1. And then what is a tan? M. So we say okay. So m square plus 1. Okay. Now sec square x dx. Sec square x dx is dm. And then the question is finished now because I'm gonna integrate as a integral, power of integral. So I'm gonna write everything as a power. So I'm gonna say this same say integral, but when you say m squared, it means m half. And then we multiply by all this stuff. This will be m squared plus 1, and then we have a dm. Now it follows the integral. So I'm gonna multiply that out. This will be m. A half plus 2 is going to be power over 2, and then we're going to plus m half, and then we have it dm outside dm, and then I can integrate here. So the question is finishing. Let's integrate. So this time we say this is a power, so we're going to integrate separately. If somebody give you integral of let's say x power 3 over 4 dx, what I'm going to do, since this is the power, so I'm going to say same as x, and then take this power here, add by 1. 3 over 4 plus 1, so say 3 over 4, 3 plus 1, and we do the same thing, take this power, and plus 1. So 3 over 4, and then plus 1. And then this one you're going to get the answer, So we're going to do the same game here. So say integral, and then we're going to 8 by 1. 5 over 2 plus 1, it's going to be 7 over 2. So 5 over 2 plus 1, 7 over 2, excuse me. 5 over 2 plus 1 is going to be m, sorry. So we're going to integrate the first one and the second one separately. So this is going to be m 7 over 2. And the same thing we're going to do at the denominator 7 over 2. And then we're going to plus a half plus 1. It's going to be m 3 over 2, and this is going to be 3 over 2. And right clear, so you can see 3 over 2, and then we're done with plus constant number. So now the question is finished, but the thing is we can leave it there. See, this same as, okay, same as, okay, so now we're going to say this 2 is going to go to the top. So to the top is going to be 2, and then m 7 over 2, 7 over 2 over 7, and then this total is going to go to the top, so we say 2, and then have m 3 over 2 over 3. So that's our final answer plus m. So this is our final answer, but the question is not completed. You know why? It's not like finally for this part after we substitute it. So we don't need m because in the equation they give us x. So brothers and sisters, so what we're going to do, we're going to have to eliminate this m. So how are we going to eliminate this m? I'm going to go back. What the value of m? M equal to tan of x. So means I'm going to raise this part here so we can finish the question. Okay, so first of all, we can eliminate what? M. So we're going to say, okay, so let me make a space here and finish this equation. But first and foremost, I can take anything which is common. What is our common? 2. If I had to take something common here, 2 could be common. Also, I could take m power 3 over 2 is common also. So I'm going to say 2 go out, and then this is m. Look, if you have a 7 over 2, and you have a 3 over 2, I can take out this common. 3 over 2 is common. If you take 3 over 2 here, look, if I take 3 over 2 here, I'm going to be left with 4 over 2. Let me say again. Some people sometimes are confusing. If you have, no, let me take it straight away. Okay, so we have a 2, 2, and then you have a m 7 over 2, and then you have m 3 over 2. But remember, these are powers. So let me break it down. So this is equal to m, and then I could say I want to take out common power. So I'm going to say, let me write is the second one how it looks. So it's going to be m 3 over 2, so times m 4 over 2, which is the same thing, because if I add the top, it's going to be 7, add the bottom, it's going to, no, excuse me. Remember, if you have the x, 3, x, 4, what you do? You write all the single base, and then you add the power, which is going to be 7 for exponential, right? So you say the same thing here. This is the same as, say, m7 over 2. You know why? Because I could write m, 1m, and then if I add the one on top, 3 over 2 plus 4 over 2, and this is going to give us what? m7 over 2. So it's the same as m7 over 2. And why I do that? I do that because for the second one, brother and sister, is m3 over 2. So I want it to look like the second part here. You see? So I'm going to say plus here, and then we have an m, 2m, 3 over 2, and then over 3, and this side over 7, and then we plus c. So you see we have something common, which is this and this one is common, so we can factor that out before you substitute back the value of m. So you're going to say 2m, 3 over 2, and you'll have m, 4 divided by 2 equal to 2 plus 1 over 3, and here we left you 7. 7 here, left here, plus 1 over 3, because this and this is common. See, and then we plus what? Constant. So now we can substitute back the value of m that I already know. So what the value of m? M equals to tan of x. So we can substitute, and that's going to be the final answer. So we're going to say, okay, finally, 2, what the value of m? Tan of x. So say tan of x, but what is the power? 3 over 2. For a bracket, so m, what is the m? M is tan of x. So we're going to say tan x by square. So we say square by over 7, and then we plus 1 over 3, and then plus our constant. And that's the final answer for this integral. So brother and sister, if this is the first time you visit my channel, make sure you click the like button and share with a lot of people. If you have more questions, you can send to me anytime, brother and sister. Peace and love, man. Peace. Peace and love. Thank you. Thank you for time. Right, so another time again, this is, let me just show everybody so that everybody can see clearly. This is Twana Wabantu Academy. I'm saying, and the aim or the purpose of solving this problem is everyone should access free, classic, quality education for all. Means, you know, the aim